Hi, my name is Carson Grin, and today I'm going to be talking about quantum computing. First of all, many people believe that quantum computers are just a faster, more powerful version of regular computers. This is false because they actually act in two completely different ways. So, a good comparison for these are a staircase and an elevator. So, they both do the same thing, but you cannot make an elevator from a staircase. The same thing is for quantum computers and computers. They both execute algorithms, but you cannot make a quantum computer from a regular computer. The reason these two operate differently is because computers use bits, which are represented as either 1 or 0, which is either an electric signal on a wire or not an electric signal on a wire. So it can use these to manipulate data. A quantum computer uses qubits, which are particles that have a percent chance of being 1 and a percent chance of being 0. So, for example, it could be a 50-50 chance that it's 1 or 0 at this specific time. The reason qubits behave this way is because they mimic the behavior of subatomic particles. So, for example, a proton or electron, because they're so small, according to quantum physics, they can be in multiple places at the same time. So this is how the qubit can have a percent chance of being 1 or a percent chance of being 0. By manipulating multiple qubits, a quantum computer can be made. An article from 2016 titled Demonstration of a Small Programmable Quantum Computer with Atomic Bits by C. Monroe, researchers made a quantum computer using 5 qubits, and with these 5 qubits it was able to execute certain quantum algorithms. Quantum computers are limited in number, but fortunately there are ways to access them, like programmers like myself. An article called Project Q Open Source Software Framework for Quantum Computing from 2018 by D. Steiger overlooks the creation of a service that allows programmers to write quantum algorithms and run them on a quantum computer. By doing this, a programmer can write a quantum algorithm in a Python file. They send the Python file to the Project Q compiler. The compiler makes it so that the code can run on a quantum computer, and then it sends it to something like IBM's quantum computer, and then the quantum computer will return the results of the algorithm that it executed to Project Q, and then Project Q will return that back to the user so they can see how their algorithm ran on the quantum computer. Because of quantum computer speed, they can be used for many different reasons. An article from 2019 titled Towards Prediction of Financial Crashes with a D-Wave Quantum Computer by E. Solano, researchers look at potential ways that quantum algorithms could solve when a financial crash might occur, which would usually be impossible for a normal computer to solve. Another way is they can be used for security. So certain encryption algorithms that are used in security are unsolvable by regular computers, but quantum computers at times can solve these different encryption algorithms. Lastly, an article from 2019 titled Training and Meta-Training Binary Neural Networks with Quantum Computing by P. Klein is about how quantum computers have the potential to train neural networks and make training of a machine learning model much faster than how fast normal computers can train them. Today we learned how quantum computers manipulate data and how they are different than regular computers. We learned how programmers can write quantum algorithms and have them run on a quantum computer remotely. Finally, we learned the possible applications of these algorithms and the potential problems that they could solve in the real world.